Hello everyone, I'm Lu Wang, a student of Jidian University in China. I'm very sorry that I cannot participate in this conference, but I really thank the chairman for giving me a chance to show my work. A multi-gene-based framework for self-adaptive software with search-based optimization. With the help of suitable solutions, SAS can automatically adjust its behaviors, structures, parameters, and other artifacts to adapt to changes of context or itself. So, planning a suitable solution to adapt to multiple, interrelated, and evolving software changes is the most important and fundamental ability. However, existing self-adaptive planning approaches based on models, rules, policies, goods, or utility all have three problems. Firstly, these approaches consider that changes of context or software are independent, but in fact the changes are interrelated. Secondly, these approaches tend to consider only one or two changes at a time. Finally, these approaches use the prioritization to determine the processing sequence of changes, and do not consider that the prioritization may be evolving. Search-based optimization is well suited to deal with multiple and complex problems. Hence, using SBO as a new self-adaptive planning approach may be a particularly promising research trajectory compared with the rule-based approaches. Search-based approach does not require professional expertise. Compared to the model-based approach, this approach does not require stricter context information, and its fault tolerance of noise and error data is also very good. Further, the search space is very large, which is the most satisfying to the real problem. And most importantly, based on the multi-objective optimization, this approach can consider the multiple changes at a time. So, this paper proposes a multi-agent framework for SAS with SBO to deal with complex changes. The following research question will be addressed. Question 1. How to design a search-based planning approach? The efficiency of SBO limits it to solve the problems of running stage. So, question 2. How to achieve online planning? Because not all software changes are complex, we think that there should not be only one kind of planning approach in SAS. So, question 3. How to design software architecture of SAS to flexibly use different planning approaches? SAS monitors managed resources, analyzes changes, plans solutions, executes solutions to adjust the software. These activities are known as the MATE cycle. Existing software architectures only establish one MATE cycle to use one kind of planning approach. So, to support using different approaches, a software architecture of SAS with double MATE cycle is proposed. In this architecture, software units, hardware, or other resources are packaged in workers. Workers can form a subsystem named as union. A manager is in charge of a union. Unions can cooperate with each other to form whole software. In addition, auxiliary is presented to support online planning. One of the MAPE cycles is in the workers to deal with the simple changes, such as the damage of resources by the rule-based planning approach. The other cycle is in managers to deal with the complex changes by using the search-based approach. In the search-based planning approach, the multiple changes are modeled as different objective functions, and the objective functions is always used as fitness function. Variable elements can be any artifacts of software as long as they can be adjusted, such as the number of resources, the parameters of software units, and even the relationships among units. Different adjustment plans of different variable elements can be combined to form a solution for changes, so an extensive search space can be established. Considering the relationship between multi-agent systems and swarm intelligence, we will design a multi-objective optimization algorithm, combine genetic algorithms and particle swarm optimization to search the optimal solution. To enhance the efficiency of the search-based approach, a method to support the online planning with the auxiliaries is proposed from two aspects, learning and searching. From the learning aspect, self-learning refers to an auxiliary can accumulate knowledge during searching the space. Meanwhile, auxiliary needs to compete with its neighborhood. From the searching aspect, auxiliaries are divided into several communities. The candidates in space are assigned to communities according to their abilities. Then, the whole space is being searched in parallel to get the optimal results as fast as possible. A corresponding workbench is being developed and based on JIT, including a toolkit and a platform. The toolkit is used in the design phase of SAS. The platform is used in the running phase of SAS. We present an evaluation plan about the internal methods decided on the scenario theory. Some scenarios are established where various complex changes may occur at the same time. The urgency and complexity of each change are defined by the analytic hierarchy process. Then, by switching these scenarios, the ability of SAS to select different planning approaches is to be verified. About the framework with the help of Workbench, this framework will be compared with Rainbow, Music, and other frameworks for SAS in the same case study of ZNN.com. The resilience, maintenance, cost, security, load, accuracy, and other aspects of the framework will be evaluated. In this paper, we discuss the feasibility and potential benefits of considering the SBO as a new kind of self-adaptive planning approach, and a multi-agent framework for SAS with SBO is proposed to use SBO planning solutions. In the future, the capacities of agents to achieve their activities of MADE cycles are being developed, and multi-objective decision-making technology are introduced to design the search-based planning approach. The task allocation and task scheduling in parallel computing are introduced in the framework to search the space in parallel. Meanwhile, the workbench is continually being developed and modified. In the end, thank the chairman for providing me with such a chance to communicate with you. And thanks very much for my instructor, Professor Qingshan Li. If you have any questions or suggestions about my work, please feel free to contact me. Thank you.